Here's another function that's defined graphically. But in this example, instead of having just individual points listed, we actually have an infinite number of points because we have a graph that goes entirely from one point to another. So it is continuous within its graph. So each of these points you see on the grid, where in red, represents an infinite number of points on this graph. A couple of things to note about the graph. We have a solid point here at the end at x equals 5. That means you do include the point, but you stop there. Up here on the far left of the graph, we have an open circle. The open circle means you go up to that point, but don't include it. If you look at everything in between on the red graph, we have an infinite number of points. You can imagine an infinite number of values here. Now those values don't include all real numbers, they only include certain x values. In particular, the lowest x value, when we look to the left, ends up being around -4. Now I say around -4 because notice the graph doesn't exist at that open circle. So it would actually just be the value that would come first on the left would be just underneath -4, so like -3.99999. And then on the right, the highest value of x we get to is over here at 5. So we have x values going from -4 to 5 because there is no break in the graph in that region. So the graph is continuous as we draw it from -4 to 5. So we need to show that the domain has values, all values, and specifically real numbers, between -4 and 5, and we want it to include 5, so including 5. Now that's what we would consider an interval of numbers instead of individual numbers. And in mathematics, instead of writing this whole statement out every time, which can become laborious, what we would like to do is have a special notation where we can list that out very quickly. That notation we're going to very frequently use is called interval notation. It's a way of writing all numbers between one number and another to include everything that's in between them. Now, interval notation always starts with the lowest value, so in this case -4, and we put a comma and then we go to the highest number that we want to include, where we want to include all values between them. And then what we do is we either use a parenthesis or a bracket next to the two numbers on either side to actually show that we're going between them. We use a parenthesis when we don't want to include the value. So -4, as you recall, was that open circle. We do not want to include -4. We want to include everything after -4 going up to 5. But 5 had a closed circle, so we want to include it, and we use a bracket to include it. So this would be a way of writing the domain out and showing that we have all real numbers between -4 and 5, including 5, but not including -4. So this is called interval notation. If we wanted to do the range that same way, and I'll use a different color to kind of describe the range on the graph, what we want to do is the range is talking about y values. So a good way to think about y values on a graph is think low to high, because we're talking about the vertical axis. The lowest part of this graph down here would be at -6, and we have that closed circle there, so we are including the -6. And the graph is continuous until it ends up here at +4. So there's no break in the graph from -6 until we get up to +4. Now, -6 was included, so we use a bracket with the -6. 4 was not because of the open circle, so we use a parenthesis. So this would be the range, and it would include all y values from -6 to 4, including the -6, but not the 4. The description for all of the different combinations you can have with the parentheses and brackets are here at the bottom of the screen, and they're also in the lecture outline. So you can read through those to look at specific examples. Let's practice identifying the domain and range with two more graphs. So again, one thing to look for when you're looking at a graph is whether it is discontinuous, that means it has a break in it, or if it's continuous. Both of the graphs we have here are continuous. There's no breaks in them. This particular graph on the right does stop at a certain point, but when you look at everywhere else, there is no break in the graph. So we would call this a continuous graph. Now, speaking of this particular graph where we have the stopping point there, that is a closed circle, so that means we do include that point. Notice at the other end of the graph just kind of goes to the edge of the grid as we see it without a solid point, without a closed or open circle or anything. That implies the graph is going to keep going. Anytime you see a graph that goes to the edge of the grid and then doesn't have a solid point, it's telling you that it stops, it's implied that that graph goes on forever in that direction. Likewise, in this first graph, notice how the edges of this graph don't have a point at them. They just go to the edge of the graph. You can imagine that that just keeps going in that same direction, both sides here. So this graph, which is a parabola, is going to go up in both on both sides, up and out. And then this graph on the right is going to go down forever. So that's one thing to note about reading graphs. Look for whether the graph ends with a point or an open circle, or whether it just kind of continues off the grid. Now, to identify the domain and range, what we want to do, again, with the domain is look left to right, because the domain is the set of x values. So you want to think left to right when you think about finding the domain. Think left to right. And when we look at this graph is going forever to the left because it's going up and out. So it's actually going technically out to negative infinity. It's going forever in that direction. And then to the right, it goes up and to the right forever. So it is going to the right forever, which would be considered infinity. Now notice I'm using parentheses with the infinities. You always use parentheses with infinity because infinity is the idea that you go forever. Okay, without ever stopping. So you're never really getting to a stopping point, so a bracket wouldn't be appropriate. For the range, we want to think up and down. So how low did we go? How high did we go? Low to high. So when we look at this graph, the lowest point would be here at the very bottom of the bowl. That would be at -3. And you always assume, unless there's an open circle, that you really are getting to that point. So we are at our lowest going to include the -3 with a bracket. And then we're going to go up to how high? Well, the graph goes forever up, so that would be infinity, and always use parentheses with infinity. In our second example here on the right, again, thinking about the domain, we think left to right. Our leftmost point of this graph is an x value of -5. Our rightmost point, notice here, the graph is going forever to the right because of the graph going down and right. So we are going to start at -5, and because it's a closed point, we're going to include it, and then we're going to go out to infinity. So one thing that can sometimes be confusing to people is they see the graph going down and want to make that negative infinity. But remember, we're thinking about the domain right now. The domain is left and right, and this is going right as well as down, and right is what we want to consider right now, and right would be to positive infinity. The range would be thinking the up and down values because we're talking about the y-axis. The lowest point on this graph, well, the graph goes forever down, so we would go down to negative infinity. The highest point, when we look at this graph, would be here at the top of this V, which would be a 4. Again, we assume that it touches there at 4 unless we see an open circle. So we'll say the highest point is 4 and use a bracket to include the 4.